Day 3 of my machine learning journey. Today, we go deeper into classification using logistic regression on the Titanic dataset. I'll explain each section of the code step by step, just like I'm learning it myself. First, we have our learning goals, which is gonna be adding more features to this dataset, and we're gonna use cross-validation for more reliable information or evaluation. And we're gonna visualize our ROC curve to understand the threshold trade-offs. So first, we're gonna import our library. In this case, we're gonna import pandas, numpy, seaborn, and matplotlib for data and plot. From scikit-learn, we're gonna import tools to split the data, pipelines, pre-processing, cross-validation, metrics, and logistic regression. So we run our cell here to import our library, and then we jump to the next cell. In this cell, we load the Titanic dataset from Seaborn. This time, I'm gonna add extra features to include family information such as siblings, spouses, parents, children, and whether the passenger was alone. We keep our target column as survived, and we drop rows with missing values so the model can train without error. So this is what we have here, the extra features, dropping the columns, and printing also the shape of both columns or both variables. In this case, we run the cell. We have about 712 rows with 8 columns, and these are our selected features: sex, age, fare, class, embark, siblings, spouses, arch, and alone. We have a preview here. For the next section, we're gonna do pre-processing and our pipeline. For this, we separate our numeric and categorical features. The numeric features are gonna be age, fare, sibling, spouse, and parch. For our categorical features is gonna be sex, class, embarked, and alone. For the numeric features, we're gonna apply a StandardScaler to put them on the same scale. And for the categorical features, we're gonna use OneHotEncoder to turn text into binary columns, in this case zeros and ones. Then we're gonna combine them with the column transformer, as we see here in the code. Finally, we're building a pipeline that pre-processes the data and then trains the logistic regression. I also add a class weight that is balanced so that the model treats both classes more fairly, since more passengers die than survive, as we see here in this section of the code. So now we're ready to run this. For our next section, which is the cross-validation, instead of doing one train test split, we're gonna use a stratified k-fold cross-validation. This splits the data set into 5 folds, each with the same balance of survivors and non-survivors. The model trains on 4 folds, then tests it on the 5th and repeats the process 5 times. We're gonna calculate the accuracy, the F1 and the ROC-AUC curve across all the folds. Then we take the mean and the standard deviation to see both performance and stability. This gives us more reliable evaluation than just one split. Now we're gonna run our cell with the code and print it with the CV_results there. The results are, for accuracy, 83, 81, 77, 78, and 78. For the F1 is gonna be on the high 70s, and for the ROC-AUC curve is gonna be on the mid to high 80s. Here we have our table with our mean and standard deviation for each of those 3 metrics. As we can see, the average score or the mean score is gonna be 79 for accuracy, the F1 score or harmonic mean 75, and the curve is gonna be 85. Next, we're gonna do the ROC curve. For this one, we hold out the 20% of the data just for the visualization. We train the pipeline on the training set, then plot the ROC curve on the test set. The ROC curve shows how the model performs across the thresholds, not just at 0.05. And what we want to see here is that the closer to the top left is better. The AUC score summarizes the curve. 0.5 means that it's guessing at random, and 1.0 means that it's a perfect separation. And this curve is going to tell us how well the model ranks survivors above non-survivors. And with that, let's gonna run the code, and this is what we have here. It has a strong left, which is always good, and since we have a AUC higher than 80, that's always a good thing. Finally, I saved the results. The cross-validation metrics go into a markdown file. The ROC curve plot that we did above is gonna be saved as a PNG file in the docs folder, and I update the repo readme with this artifact so everything is documented. So let's run that cell. The first one that is gonna save our results as a markdown file, and we're adding the notes here, and here it is. And that's day 3. To summarize, we added more features to this classification model. We used cross-validation and learned how to interpret the ROC curve. Step by step, I'm building both skills and projects and sharing the journey with you in English and Spanish. Subscribe if you want to follow along. The GitHub repo link is in the description below. Thank you so much, and I hope you have an awesome day. Take care.